Hello class, my name is Dr. Heath Hooper and I'm your instructor for MAIG 503 International Social Research Methods. We are in week 7, the last week of the course, and this is our last PowerPoint presentation that we have for the course. And in today's lecture and lesson, we're going to talk about multivariate analysis as well as statistical analyses. So with that being said, we'll go ahead and get started with this week's lesson. All right, so week 7, we're going to cover chapters 15 and 16, the logic of multivariate analysis and statistical analyses. So let's first start off by defining multivariate analysis, the analysis of the simultaneous relationships among several variables. This is one that you will use in a statistical analysis. So when you get to the methodology section, this may be one that you decide you want to use. Also, an elaboration model is a logical model for understanding the relationship between two variables by controlling for the effects of a third. So a moderating variable would be that third variable. An elaboration model is what encompasses those three. Test variable, a variable that is held constant in an attempt to clarify further relationships between two other variables. Test variables are also called control variables. So that's the variable that you would test in a project methodology research. Descriptive statistics, statistical computations describing either the characteristics of a sample or the relationship among variables in a sample. Your descriptive statistics are going to be the foundation of what your statistical computations consist of. So in a quantitative study, you're going to have descriptive statistics, obviously, and that is the characteristics or the computations of your sample, all right? Interval and ratio variables, Pearson's product moment correlation. This is a type of statistical analysis, descriptive statistics. Pearson's R correlation. It's how they correlate to one another between the variables. A regression analysis is a method of data analysis in which the relationship among variables are represented in the form of an equation called a regression equation. And here we're going to have some examples coming up on that, but more so regression analysis, a linear regression and a multiple regression. So a linear is a form of statistical analysis that seeks the equation for the straight line that best describes the relationship between two ratio variables. So when we look at a chart, which we'll look at in a second, you'll see a linear regression line. A multiple regression analysis is a form of statistical analysis that seeks the equation representing the impact of two or more independent variables on a single dependent variable. Okay, so two or more independent on a single dependent. Here is an example of linear regression. Okay, so here's the line and here's all of our points of chart with the sample, all right, where they fall on the chart line. So linear regression has two, unexplained variation and explained variation. A multiple regression is a form of statistical analysis that seeks the equation representing the impact of two or more independent variables on a single dependent variable. Here's your regression line equation, all right? The A is the y-intercept on the axis where the regression line crosses the y-axis. The B, little I, is the slope, the change in y for every 1 unit in change x. And then x little I is the independent variable and y is the predicted value of the dependent variable. So here is that equation. Here is a different one, regression line. Okay, so we had one regression line equation. Here's a different regression line equation. This basically includes the residual or error for what is to be expected. So most of the time, your 95% confidence level, that is your interval there, okay? That's your error of what is to be expected. More so on multiple regression, they have a partial regression analysis and a curvilinear regression analysis. A partial is a form of regression analysis in which the effects of one or more variables are held constant, similar to the logic of the elaboration model, as we discussed. A curvilinear regression analysis is a form of regression analysis that allows relationships among variables to be expressed with curved geometric lines instead of straight ones. So curvilinear, curved lines, self-explanatory. Inferential statistics, the body of statistical computations relevant to making inferences from finding based upon sample observations to some larger population. Most of the time, this is a statistical analysis that many will use because it's based on the sample observations, and then you apply that to the larger population. That's simple research. That's simple methodology there. Take your sample, apply it to what you believe, how it represents the population. Here's some examples of inferential statistics. So independent variable, you have nominal, ordinal, and interval ratio, all right? So nominal, crosstabs, chi-square, interval ratio, t-test, ANOVA, ordinal, and then interval ratio. So these are very important in labeling in your study, and then the dependent variable as well. So you want to make sure that you have the correct inferential statistics, statistical analysis that you're using for the correct study, all right? Now here's the test of statistical significance. So let's first define statistical significance. It's a term referring to the likelihood that a relationship observed in a sample could be attributed to sample error alone. And then you test this with a statistical computation that indicates the likelihood of the relationship between the variables in the sample can be contributed to the sample error alone, okay? So pretty much the same definition there. We're testing the sample error. And then the level of significance in the context of tests of statistical significance, the degree of likelihood that an observed relationship could be attributed to the sample error. For example, a relationship is significant at the 0.05 level if the likelihood of it being a function of sampling error is no greater than 5 out of 100. So back to the 95% as I stated a few slides ago. Chi-square, this test is based on the null hypothesis. So for each cell in the table, subtract the expected frequency for that cell from the observed frequency. Square that quantity and then divide the square difference by the expected frequency. That's how you come up with the chi-square. A t-test is a measure for judging the statistical significance of differences in group means. And let me kind of reiterate this. This is quantitative analysis here. This is not mostly qualitative. This is mainly quantitative statistical analysis that you would use in a quantitative study. Now, the logic for the t-test is we're measuring or judging the statistical significance of differences in group means. So you're taking the averages. So the logic behind this, the value of t will increase with the size of the differences between the means. The value of t will also increase with the size of the sample. And then the value of t will be larger when variations of values within each group are smaller. Type 1, type 2. Type 1 error is incorrect rejection of the null hypothesis. All right, so if you reject the null hypothesis but end up finding out that that was incorrect, that is a type 1 error. Type 2 error is an incorrect acceptance of the null hypothesis. So let's say we accept the null hypothesis, but we ended up being wrong with that. That is a type 2 error. Here's some words of caution, just some advice here. There are no objective tests of substantive significance, only objective significance. Statistical significance is only appropriate for samples, not the whole population. As we've discussed, your sample size is what is represented here. Tests of significance are based on the same sampling assumptions used to compute confidence intervals. All right, so just kind of be aware of those things. A more, I'd say complex multivariate statistical analysis is an analysis of variance. This is called an ANOVA. The method of analysis in which cases under study are combined into groups representing an independent variable and the extent to which the groups differ from one another is analyzed in terms of some dependent variable. To the extent to which the groups differ is compared with the standard of random distribution. This is more of a complex type statistical analysis, an ANOVA. And then you have a one-way ANOVA and a two-way ANOVA. So a one-way is a bivariate analysis that seeks to determine which groups on the dependent variable differ from each other in terms of some dependent variable. Two-way is a multivariate technique which permits the simultaneous examination of more than two variables. All right, so you definitely need to read through the Babby text on those to get a better explanation. That's just a brief overview of kind of the description there. Also, if you have questions going forward about any of these statistical analysis, I'm more than happy to help you through that. It has been a pleasure to have you all in class. It's been a pleasure working with you, seeing your growth and seeing how you've excelled throughout these assignments and into your culmination assignment. So I look forward to reviewing your final presentation and your final paper. And anything I can be of assistance with, please let me know. Once again, my email is heath.hooper@cui.edu. Thank you all so much, and I look forward to seeing you again soon. Have a blessed week.